Okay, this is a grade 10 question on quantitative chemical change. It's question 6 from November 2019. Remember, when you do any of these chemistry calculation questions, you will need all of the things from your periodic table, the formulas and the periodic table and other things from the data sheet. So it says the first step in the extraction of zinc from zinc sulfide is the combustion of zinc sulfide in oxygen. The balanced equation for the reaction is 2 zinc sulfide plus 3 oxygen goes to 2 zinc oxide plus 2 sulfur dioxide plus energy. It says, is the reaction above exothermic or endothermic? Now this reaction is exothermic. How can we tell it is exothermic? If you look, here is the reaction arrow, and here one of the products is energy. So it gave 1, 2 chemical products, and the third product was energy. So it is exothermic because energy is released in the reaction. Remember, there's more than one way of showing an exothermic reaction, but in grade 10, this is a pretty common way. If the energy was in front of the reaction arrow over here, then it would be an endothermic reaction because you have to add energy to start it. Now let's have a look at this next question. It says, oxygen gas consists of oxygen molecules. Define the term molecule and draw a Lewis dot diagram of the oxygen molecule. So let's have a look here. What is a molecule? It's 2 or more atoms that are covalently bonded and function as a unit. Now the more interesting part is the Lewis dot diagram of the oxygen molecule O2. So when we start drawing Lewis dot diagrams, we need to know how many valence electrons we have. That is the basis of a Lewis dot diagram, is knowing how many valence electrons we have. So if you come to your periodic table, here is our friend oxygen, which has got 8 and 16. So if you want to, you can go oxygen 1s2, 2s2, so that's 4 of my electrons, 2p, 4. Now I've got 8 electrons because remember, if you have a look at this oxygen molecule, this 8 over here is telling you the protons and the electrons, and this 16, the mass number, is telling you the protons plus the neutrons. And we're only interested in the electrons when we draw a Lewis dot diagram, and we are only interested in the outer shell valence electrons. So here we've got 6 valence electrons because those are the ones in the unfilled second shell. The first shell is filled, so we've got 6 valence electrons. If you didn't want to go through the 1s2, 2s2, 2p6, you can come up to this on the top of the periodic table, and this says VI. If we look at the old numbering, it says VI, and VI is the Roman numeral for 6, which is the number of valence electrons. So you can see 6, the halogens have 7, the noble gases have 8, which is a nice stable structure for the noble gases. Remember, we're striving to get this 8 valence electrons. So if we drew an oxygen atom, it would be 1, 2, 3, 4, 5, 6 valence electrons, and this is the Lewis dot of an oxygen atom. But they want the oxygen molecule. So to draw the oxygen molecule, we have 2 oxygens next to each other. Now, if there's 2 oxygens, that means we are going to have 2 times 6 is 12 valence electrons. And we have to arrange these valence electrons in such a way that each oxygen thinks it's got a nice noble gas structure of 8. So if we start out, we know that each of these 1, 2, 3, 4, 5, 6, and this dude will have, and I'm going to draw them as crosses so you can see what's going on, 1, 2, 3, 4, 5, 6. Okay, so these two would be like this if we just pushed them together. But if we look at this, we can't have this unpaired situation in the middle. So what we could maybe do is we could say, alrighty, let's take that electron off and leave this over here. And look, I've got this let me draw this nicely in the middle here. I've got these two oxygen atoms and they're covalently bonded because we've got 2 electrons in the middle being shared. So then if the 2 electrons are being shared and we look at this oxygen atom on the left and we count it, 1, 2, 3, 4, 5, 6, 7 electrons. And if we look at the one on the right, 1, 2, 3, 4, 5, 6, 7 electrons on the right. They both think they've got 7 electrons because these 2 in the middle over here are being shared. But we don't want 7 valence electrons, we want 8. So in order to get 8, we have to trick these atoms somehow, and the way that we trick them is that we will take this oxygen's little electron that was by itself, and we're going to put it in the middle, and we're going to take this oxygen's electron that's over there, and we're going to put it in the middle. And now it's not very neatly drawn, but if we have a look, we have an oxygen-oxygen double bond like this. And if we look at this oxygen on the left, it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. And the one on the right has got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this one thinks that this is quite a happy molecule. They both think that they have 8 electrons, but I haven't drawn it very tidily. Okay. So if I were to draw it more tidily, I would just make it look a bit more symmetrical like this. So it's exactly the same structure I'm drawing here, but the one is just slightly more symmetrical than the other. Can you see I left these 2 on the left and those 2 on the right? Better to make it more symmetrical like that because molecules like to be symmetrical. So to draw the Lewis dot diagram, you find the valence electrons, you put the atoms next to each other, you share electrons between the 2 atoms, and then you rearrange the electrons until both atoms think that they've got 8 electrons. Then what's the last part of the question? It says, during the reaction above, 7 grams of zinc sulfide reacts completely with oxygen gas. So this is this reaction over here. Okay. And it says to you, 7 grams of zinc sulfide reacts completely with oxygen. Calculate the number of moles of zinc sulfide that has reacted. So we are looking for N in the formula. We are looking for the N of zinc sulfide. And we have 7 grams. This is little m, the mass. And so what do we have? Which formula do we have that links mass and number of moles? It is this formula here. So it is mass over molar mass. So the mass that we have in grams is 7. So now we need to find the molar mass of zinc sulfide to answer this question. So the answer to this comes from the periodic table. We go to the periodic table, we find zinc. Zinc has got a molecular mass of 65. Oxygen has, oops, we're not looking for oxygen, we are looking for sulfur. Sulfur has a mass of 32. So if we add those 2 together, we end up with 97. 65 and 32 is 97. The molar mass of zinc sulfide is 97 grams per mole. And so if we then put this number in our calculator, we will end up with 0.07216. Now, I know the question paper says round off to 2 decimal places. But if you round off to 2 decimal places, you will lose a lot of accuracy here. So it's always better to have your answer to 2 or 3 significant figures. So this one, you'll see the memo rounds off to 0.072. Or the most accurate way to write this will be 7,22 times 10 to the negative 2 in scientific notation. And then that's 2 decimal places in scientific notation. But we will stick with what the memo is using, which is 0,072, which is not 2 decimal places. It's 3 decimal places, but it is 2 significant figures. Okay. Now the next part says to you, we found the number of moles of zinc sulfide that reacted. And the question says they react completely with oxygen gas. So if they say react completely, they mean they reacted exactly how it is in the balanced equation. Now it says what mass of oxygen is needed. So your chemical equation is like a recipe. 3 eggs need 2 cups of sugar. 2 zinc sulfide needs 3 oxygen. So if we know how much zinc sulfide we used, which is 0,072, we can figure out how much oxygen is needed to react completely with this. So we have to do a ratio calculation. So to do the ratio calculation, we're going to multiply that one and then that one. If this is x, we will end up with 0,072 multiplied by 3 divided by 2. So just do the ratio calculation, set it out the same way every time, and you will end up with your answer, and you get 0,108 moles of oxygen, okay? Because we can't just go straight to mass. We always have to find the moles from the balanced equation before we find the mass. So the moles of zinc sulfide will tell us how many moles of oxygen are needed, and from there we can go and convert the moles into mass, again using the same formula. The number of moles of oxygen will be equal to the mass of oxygen over the molar mass of oxygen. The balanced equation tells us for 0,072 moles of zinc sulfide, we need 0,108 moles of oxygen, and this will be the mass over the molar mass of oxygen. So if we look on our periodic table, my oxygen is 16, so the molar mass of oxygen is 16 plus 16 because there are 2 atoms, so this is 32. So if we do some little bit algebra here, we will end up with, what is this, 3,456 grams, which we can round off to 3,46 grams. So we need 3,46 grams of oxygen. Now the last part of the question says, calculate the volume of sulfur dioxide produced at STP. So the moment we see these little letters STP, we are going to use this formula. The only other time we can use this formula is when you see the words molar gas volume in the question. Because remember, STP is standard temperature and pressure, and at standard temperature and pressure, there on your data sheet, the molar gas volume is 22,4 cubic decimeters per mole. If the experiment is not done at STP, the molar gas volume increases, and then they give it to you in the question. But the only time you can be using this N equals V over Vm is if you see the words STP or you see the words take the molar gas volume to be. Because this one is Avogadro's law, it is only for a gas. So my number of moles of sulfur dioxide will be equal to the volume of sulfur dioxide over the molar gas volume. My only problem here is I don't know how much sulfur dioxide I'm going to produce in moles. So to figure that out, we have to take what we were given in the question, which is the zinc sulfide, and we have to check the mole ratio with the sulfur dioxide. So the mole ratio for the zinc sulfide to the sulfur dioxide is a ratio of 2:2. Okay, so 2:2, if we simplify it, it's the same as 1:1. So you need to put this step here to get all of the marks in this question. You need to prove that you know that the balanced equation is ruling everything. It's the king. It tells you 2 moles of zinc sulfide produce 2 moles of sulfur dioxide. So the number of moles of sulfur dioxide will be the same as the number of moles of zinc sulfide, which remember we calculated over here. So this is 0,072 is going to be equal to the volume of sulfur dioxide over the molar gas volume, which is 22,4. So if we put that in our calculator, we will end up with 1,612 cubic decimeters, which you can round off to 1,61 cubic decimeters. In the memo, it says 1,62 cubic decimeters. And the reason for that is not bad rounding, is that they took this whole value, which is what you're supposed to do, 7/97. If you put 7/97 in your calculator, and multiply by 22,4 the molar gas volume, you will end up with 1,616, which rounds off to 1,62 cubic decimeters. So you get 1,62 cubic decimeters if you kept the number in your calculator. Okay, so if you keep the number in your calculator, you get the most accurate answer to the final step, but they will normally give you a range of acceptable values. Then finally, the very last part of the question, it says, consider the incomplete equation for the chemical reaction below. Zinc solid plus H2SO4 aqueous goes to X plus H2 gas. Now it says write down the name of the acid in the equation above. You can always identify an acid because they have an H in the front of their name. This acid is sulfuric acid. Okay, I will accept both spellings of it, but this is the more correct spelling, and it is aqueous, so it's definitely sulfuric acid. Now it says write down the formula of product X. So now this is a balanced equation, people. On the left-hand side, I have zinc, hydrogen, and a sulfate ion, and on the right-hand side, I currently only have hydrogen. So how do we know what the product is? We know it has to be made up of zinc and the sulfate ion because they are the only things that are not on the right-hand side. So it actually makes zinc sulfate, and if you know your table of cations and anions, you know that the zinc ion is 2 plus and the sulfate ion is 2 minus. So when we make zinc sulfate, we only need one zinc ion to one sulfate ion to make it neutral. So that is absolutely the correct formula. Now it says to you, name the type of reaction illustrated above. Choose from acid-base reaction, precipitation reaction, or redox reaction, and explain your answer. So when you learn your general reactions of acids, this one is a metal plus an acid gives you a salt and hydrogen gas. Okay, so now we do learn this when we learn acid-base, but this is technically not an acid-base reaction. This one is actually a redox reaction because on the left-hand side of the equation, zinc is an element. Okay, and on the right-hand side of the equation, it is an ion. It is a cation. So how did you get from the element to the ion? You have to have lost 2 electrons. In the same manner, if zinc is losing the electrons, something must be gaining the electrons. And if you look at the sulfuric acid contains 2 hydrogen ions or protons, and on the left-hand side, they went from being an ion, and on the right-hand side, they are hydrogen gas, which is an element. So how did this happen? These two had to have gained 2 electrons. To go from a positive charge to neutral, you have to have gained 2 electrons. So because electrons were transferred, this is a redox reaction. Then it says, briefly describe a test that can be used to verify the formation of hydrogen gas during the reaction above. If you use a lighted splint, okay, remember a lighted splint is like that long matchstick or a lighted match, but they always say use a lighted splint. Use a lighted splint. The gas, if you trap it in a test tube, will make a popping noise. That's that little popping noise that tells you there is hydrogen present. If there was oxygen present, a glowing splint would glow brighter. If there was carbon dioxide, you bubble it through lime water. But this is the test for hydrogen. A lighted splint makes a popping noise.